Okay, so you've given us a ton of material on nutrition and healthy living.
A lot to unpack.
Yeah, really interesting stuff. So today, we're going to like really plunge into it.
Dive deep.
Yeah, deep dive. Pull out the most valuable stuff, make it all make sense, and hopefully have some aha moments.
Okay.
All right. So the core of it is this textbook, Nutrition for Healthy Living, second edition by W. Schiff.
It's a really fantastic resource.
Yeah, super comprehensive, like from the basics all the way to how we actually use this stuff in our lives.
Exactly.
So the mission here is to basically arm you with some, solid nutrition knowledge, those aha moments, and to give you a clear picture of how the food you eat impacts your health.
Make it all come together.
Exactly. All right. So I guess first things first, what are the basic things we need to know about, what's in our food?
Well, I think the first thing to understand is the concept of essential nutrients. So these are substances that your body can't make on its own, or at least not enough of them. So you absolutely have to get these from the food that you eat.
Got it. So you can't just like wish away a vitamin deficiency or something.
Nope.
One thing that caught my eye in the book was this idea that, most natural foods are actually these like incredible mixes of nutrients. It's not just like, oh, this is protein or this is carbohydrate.
Yeah,
Right?
no, it's definitely not that simple. Like if you think about milk, for instance,
Okay.
it's actually about 91% water. But then within that water, there are significant amounts of protein, carbohydrates, some fat, a whole range of vitamins and minerals.
Wow. Okay.
It's really fascinating.
Yeah. So it really is like this nutritional powerhouse. Even a baked potato, which I just think of as carbs, it's mostly water.
Right.
It's also got like a surprising amount of iron and potassium and vitamin C and niacin in there.
Yeah,
So it really makes you look at these like basic foods differently.
absolutely. And to kind of break it down, we categorize these components of food into what we call macronutrients and micronutrients. So macronutrients, those are the ones you need in larger amounts every day. Carbohydrates, fats, and proteins. And then you have the micronutrients. Those are the ones you need in smaller quantities. These are vitamins and minerals. And then, of course, there's water. But we don't classify water as a macronutrient
Okay.
because it doesn't provide energy.
Got it. So it's like essential, but it's in a category of its own.
Exactly.
So then when we talk about energy, like how do we actually measure the energy that we get from food?
So we use kilocalories, or often just shortened to calories.
Yeah.
That's the unit we use to measure the energy content of food.
Okay.
So carbohydrates and proteins, those provide about 4 kilocalories per gram. Fat is much more energy dense at about 9 kilocalories per gram. And alcohol, even though it's not a nutrient, it actually provides energy.
Okay.
About 7 kilocalories per gram.
Interesting. So a little bit of food math involved.
Right.
Okay, so we've got the basics down. Now, the book also goes into how our eating habits and overall health have changed over time, especially in America.
Right.
What are some of the major changes that, have happened over the years?
Well, one striking thing is how our eating patterns have evolved since about 1970.
Okay.
The data shows that we are, on average, consuming more fat, more added sugar, and a greater number of calories per day than we were back then.
Yeah, that makes sense when you think about all the processed food and stuff that's out there.
Exactly. And we've also become a lot less physically active during that same time period.
True. Yeah, we have so much technology and stuff that, it's just left work.
Yeah. Makes life easier in a lot of ways, but we're not burning as many calories just in our daily routines.
It's like a double whammy. You're putting more calories in and not using them up.
Exactly.
And so, not surprisingly, that has consequences for our health. The book mentions that there's this link between lifestyle factors and some of the leading causes of death in the U.S.
Yeah, that's right. Figure 1.3 in the book shows this really clearly. Diet, physical activity, smoking, alcohol consumption. These all contribute to things like heart disease, stroke, certain types of cancer.
Yeah, it really shows how much our daily choices matter. Right?
Absolutely. It's not just about, trying to avoid getting sick. It's about actually reducing your risk.
Right.
Your everyday habits can either make you more likely to get sick or actually help you prevent it.
Okay. So we're bombarded with all this nutrition information all the time these days. How do we know what to believe? Like what's trustworthy and what's just nonsense?
That's a really important point. And the book has some really helpful advice on how to evaluate nutrition claims.
Okay, good.
So one of the biggest things to watch out for is relying on information from a single study especially if it's making like really sweeping claims about health.
You see those headlines all the time.
Right, exactly. Nutrition research is complex and findings often need to be confirmed by multiple studies. So we need to see that consistency before we can really say, okay, this is something that's reliable.
Got it. The book also pointed out some things that are just flat out not true, like tailoring your diet to your blood type, or that, having an alkaline body can prevent cancer.
Yeah, those don't have any solid scientific backing.
Yeah.
And another thing, too, it's really important to look at the source of any online nutrition information.
Makes sense.
Be really careful about websites that are mainly trying to sell you products, especially if they have like lots of disclaimers in the fine print.
Yeah, that's a good tip.
That's usually a big red flag.
What about, like, if you're reading something in a magazine versus a scientific journal? Is there a difference in how much you should trust that information?
Yeah, that's a really key distinction. So scientific journals usually publish articles that have gone through this process called peer review,
Okay.
which means other experts in that same field have basically evaluated the research.
Ah.
So it's like a stamp of approval. Popular magazines, they might report on some scientific findings, but it doesn't necessarily have that same level of scrutiny.
So peer review is really important.
Absolutely.
Got it. Now, the book also talked about different types of research studies. What are the main kinds?
Yeah, so there are observational studies, like case control studies, where they compare people who have a certain condition to those who don't.
Okay.
And that helps to look for potential risk factors. There are also cohort studies where they follow a group of people over a long period of time.
Got it.
And then there are experimental studies that are designed to, test a specific intervention,
Okay.
like the effect of a certain diet.
So there are a lot of different ways to, like, figure out what's going on with nutrition.
Yeah, exactly.
All right. Shifting gears a little bit, the book goes into dietary recommendations and all the tools that are out there.
Right.
And this feels like learning a whole new language with all the acronyms.
It can definitely feel overwhelming.
Okay.
So we have the dietary reference intakes, or DRIs. These are a set of recommendations for healthy people in the U.S. and Canada.
Okay.
And within the DRIs, there are different values, like the EER, the estimated average requirement. That's basically the intake level that's estimated to meet the needs of half the people in a specific group. Then there's the RDA, recommended dietary allowance.
Okay.
That one is set to meet the needs of almost all healthy individuals,
Yep.
like 97 to 98%. And then when there's not enough data to set an RDA, we use the AI, the adequate intake, which is basically based on observations.
Got it.
We also have the UL, which is the tolerable upper intake level. That's the highest level that's likely to pose no risk of adverse health effects. And lastly, there's the estimated energy requirement, or the EER, which helps us estimate the calorie intake to maintain energy balance.
Wow, that's a lot to keep track of.
It is.
So those are the, like, guidelines that the experts use.
Right.
What about when we're, at the grocery store looking at a label? Like, what are we actually seeing there?
So those are the daily values, or the DVs.
Okay.
And those are based on a 2,000 calorie diet.
Yeah.
And there, what you see is those percentages on the nutrition facts panel. And it's important to note that DVs only exist for some things, like total fat, cholesterol, fiber, some vitamins and minerals.
Okay.
Not for things like protein, sugar, trans fat.
Interesting. So you just see the grams, not the percentages.
Right.
Okay. So the nutrition facts panel, it gives you the serving size, calories, and then those percentages.
Right.
So it's kind of like a snapshot.
Exactly.
Okay. The book also touches on organic labeling. Like, what does that all mean?
Yeah, so organic labeling has a few different categories. So 100% organic means that all ingredients are certified organic.
Okay.
Organic means at least 95% are organic. And made with organic ingredients means between 70% and 95% of the ingredients are organic.
Got it. So it's good to know what those labels actually mean.
Right.
There's this concept of nutrient density.
Yes.
What is that all about?
Nutrient density is basically how many nutrients a food provides compared to its calories.
Okay.
So a nutrient-dense food is packed with vitamins and minerals and fiber, but it's relatively low in calories.
So basically, you're getting the most bang for your buck.
Exactly.
Okay. So we've talked about what we eat and how to understand the labels.
Yeah.
Now let's talk about what happens after we eat.
Okay.
The book gives a great overview of the digestive system.
Yeah.
It's a pretty incredible process, isn't it?
It really is. So the basic function of the digestive system is to break down the food we eat into molecules that our body can absorb.
Okay.
And it's a really complex process involving a whole bunch of different organs.
Yeah.
Starts in the mouth, travels down the esophagus to the stomach, then to the small intestine,
Okay.
and then finally the large intestine.
And we have these other organs that, play a role too, right?
Yeah, we have the accessory organs, which
Yeah.
are the liver, gallbladder, and pancreas.
Right.
They're not directly part of the path that the food takes,
Okay.
but they're super important for the process.
Got it.
So the liver produces bile, which gets stored in the gallbladder and released into the small intestine to help us digest fats. And the pancreas secretes all sorts of different enzymes,
Okay.
including pancreatic amylase, which helps break down carbohydrates.
Right.
So all these pieces are working together.
So let's talk about carbohydrates.
Okay.
The book goes into how they're digested.
Right.
And I thought it was interesting that it starts in the mouth.
Yeah, it does, with salivary amylase,
Right.
which breaks down starches, but then that process stops in the stomach.
Right, because of the acid.
Yeah, the acidity deactivates the salivary amylase, but then digestion picks up again in the small intestine
Okay.
because of pancreatic amylase. And the small intestine is where carbs are broken down into these sugars,
Okay.
and then those sugars are absorbed into the bloodstream.
So what about fats? What happens to those?
Fats, or lipids, are a pretty diverse group of substances.
Okay.
They include fatty acids, triglycerides, phospholipids, and cholesterol.
Oh.
And they don't dissolve in water.
Right.
So that's why, oil and water don't mix.
Okay. And then there are these trans fats, which we're always told to avoid.
Right. So trans fats are a type of unsaturated fatty acid, and small amounts actually occur naturally in some animal products.
Oh,
But most of the trans fats that we eat come from processed foods.
okay.
They're formed during this process called partial hydrogenation, which changes the structure of the fat.
Okay.
And structurally, they're actually pretty similar to saturated fat.
Oh, I see.
So they have similar negative effects on health.
So when you see a food that's like partially hydrogenated,
Right.
that's a clue that there are trans fats in there.
Exactly.
Okay. What about cholesterol? It seems to have a bad reputation.
Yeah, it does. But it's actually really important.
Okay.
It's a type of lipid called a sterol. It's a part of all of our cell membranes. Our body uses it to make vitamin D, steroid hormones. The liver uses it to produce bile. So cholesterol itself isn't inherently bad. It's all about managing your cholesterol levels.
So like how much you have.
Exactly. And to transport all these fats around, since they don't dissolve in water, we have these things called lipoproteins.
Right.
Those are like tiny taxis that carry lipids through your bloodstream.
Right.
And examples of these are chylomicrons and LDL. LDL is often called bad cholesterol
Okay.
because high levels of it can build up in your arteries.
Got it.
And then there's HDL, which is often called good cholesterol, which helps remove cholesterol.
So it's all about like balance.
Exactly.
All right. So we've talked about carbs and fats. Let's move on to proteins.
Yeah.
What are the like basic building blocks of proteins?
So proteins are made up of amino acids, and there are two main types. There are essential amino acids, which your body can't make.
Okay.
So we need to get those from our diet. And then non-essential amino acids, which your body can make on its own. Each amino acid has this central carbon atom. It's bonded to an amino group, an acid group, and then this unique side chain,
Okay.
which gives each amino acid its specific properties.
Got it.
And interestingly, when the nitrogen-containing amino group is removed from an amino acid, that carbon skeleton can be converted into glucose and be used for energy.
Wow. Okay. So it's not just about building muscle and tissue. It can also be used for energy.
Right.
All right. So we can't forget about the micronutrients, vitamins, and minerals. And the book gives a lot of information on all these.
It does.
Let's talk about some of the, the key highlights.
Okay, sure. So vitamins are these organic compounds you need in small amounts.
Okay.
And they're classified as either fat-soluble, which are vitamins A, D, E, and K,
Got it.
or water-soluble, which are the B vitamins and vitamin C.
Okay.
Let's start with vitamin A.
Okay.
So it's really important for vision, immune function, cell growth. Good sources are liver, milk, and those brightly colored orange and dark green fruits and vegetables.
Okay.
But taking very high doses can be toxic.
Oh, wow. So more isn't always better.
Right, exactly.
Yeah.
What about vitamin D?
Yeah, that one we hear a lot about.
Yeah, so vitamin D is really important for helping your body absorb calcium and phosphorus.
Okay.
Those are essential for strong bones and teeth.
Yeah.
You can get it from some foods. Fortified milk. And of course, sunlight.
Right. Yeah.
And the book mentions that vegans and people who are lactose intolerant might be at higher risk for vitamin D deficiency
Yeah, that makes sense.
because of the calcium connection.
Okay. What about vitamins E and K? What are their main roles?
Vitamin E acts as an antioxidant,
Hmm.
helping to protect your cells from damage.
Okay.
Vitamin K is essential for blood clotting.
Got it.
And then we have the B vitamins.
Uh-huh.
Those are a whole group of water-soluble vitamins that act as coenzymes.
Okay.
They help your body convert food into energy.
Got it.
One of them, vitamin B12, is mainly found in animal foods. So vegetarians and vegans need to be mindful of getting enough.
Okay.
And of course, vitamin C. Also known as ascorbic acid, it's important for making collagen,
Okay.
which is a part of connective tissue. It's also an antioxidant. Good sources are fresh fruits and vegetables.
Okay.
But it can be lost during cooking. So eating those foods raw or lightly cooked is ideal.
Okay.
And smoking can actually increase your need for vitamin C.
Wow, that's interesting.
Yeah.
Okay, so that's a great overview of vitamins. Now let's talk about minerals.
Okay, so minerals are these inorganic elements. Let's start with calcium.
Yeah.
We know it's super important for bone health.
Right.
Dairy products are a great source. Leafy green vegetables also have it,
Okay.
but it might not be as easily absorbed.
Okay, so there's like a difference in the bioavailability?
Exactly. And then sodium.
Right, which seems like it's in everything.
It is in a lot of things. Too much sodium is linked to high blood pressure,
Okay.
and processed foods are a big contributor to that.
So something to be mindful of.
Definitely. What about iron?
Yeah.
Iron is crucial for carrying oxygen in your blood. If you don't have enough, you can get anemia. Heme iron, which comes from animal products, is better absorbed than non-heme iron, which comes from plants.
Okay.
Zinc is important for lots of enzymes and for immune function.
Got it.
Iodine is essential for thyroid hormone production.
Okay.
And if you don't have enough, you can get problems like goiter.
So it's all about getting enough of these, but not too much.
Yeah, exactly.
The book warned against taking mega doses of vitamins and minerals.
Yeah, that's right. Because even though your body needs these things, taking too much can actually be harmful.
Wow.
High doses of niacin can cause problems with your skin and even your liver.
Okay.
Too much vitamin B6 can cause nerve damage.
Wow.
And even vitamin C, which people often think of as, completely harmless, really high doses, haven't been proven to be beneficial
Interesting.
and might even have some risks. So balance is key.
So it's all about moderation, right?
Absolutely.
All right. So we talked about the fuel we take in, these helpers that keep our bodies running. Now let's talk about energy balance.
Yeah.
Like the calories we consume versus the calories we burn and how that plays into our weight.
Right. Energy balance basically means if the number of calories you take in is about the same as the number of calories you burn, your weight will stay stable. If you eat more than you burn, you gain weight. If you burn more than you eat, you lose weight.
Makes sense.
Pretty straightforward.
And BMI, that's a tool we use to figure out if someone's weight is in a healthy range.
Yeah, BMI or body mass index is a calculation based on your weight and height.
Okay.
And it's used to classify people as underweight, healthy weight, overweight, or obese. But it does have limitations. It doesn't actually measure body fat.
Oh, okay.
So that's where the idea of body composition comes in. Looking at how much of your body is fat versus lean tissue, like muscle.
So someone could have a high BMI but still be healthy if they have a lot of muscle.
Exactly. And the book also talks about the difference between subcutaneous fat, which is the fat under your skin, and visceral fat, which is the fat around your organs.
Okay.
And that visceral fat is actually more concerning for health.
So it's not just about how much fat you have, but also where it is.
Right. Exactly.
Okay. What are the main things that affect how many calories we burn in a day?
Mhm.
It's not just exercise, right?
That's right. So your total daily energy expenditure is made up of a few different things. Basal metabolism, which is the energy your body uses just for basic functions,
Okay.
like breathing, keeping your heart beating.
Got it.
Then there's the energy you expend through physical activity.
Right.
Then there's the thermic effect of food, or ET.
Okay.
That's the energy your body uses to digest and absorb food.
Okay.
And lastly, there's NEAT, non-exercise activity thermogenesis.
Okay.
That's basically all the energy you expend through activities that aren't exercise.
Okay.
Like fidgeting, walking around, doing chores.
So all those little things add up.
They do.
What about hunger? Like what makes us want to eat in the first place?
So your body has this system of hormones and signals that regulate hunger and satiety.
Okay.
For example, ghrelin is a hormone that stimulates hunger.
Oh, yeah.
And then there are hormones like peptide YY that signal fullness.
Got it.
And then there's the hypothalamus in the brain, which receives those signals and helps regulate appetite.
Interesting.
There are also environmental factors like the availability of food and our lifestyle that can influence our weight, and even genetics play a role.
Yeah, for sure.
And the book even mentions this idea of a set point theory, which suggests that our body might have a predetermined weight it tries to maintain.
So that might explain why weight loss is so difficult for some people.
Right.
Okay, so for those who are trying to lose weight, what does the book suggest?
So a healthy weight loss plan really boils down to three things.
Okay.
Calorie reduction,
Okay.
regular physical activity,
Got it.
and behavior modification. So reducing your calories, typically aiming for a deficit of about 500 calories per day to lose about a pound a week.
Okay.
And then regular physical activity.
Got it.
And then finding ways to change your behavior to support those other two things.
Got it.
And the book really emphasizes reducing your intake of added sugars, unhealthy fats, and alcohol,
Okay.
while still making sure you get all the essential nutrients.
Right, so you don't want to, like, starve yourself.
Right, exactly. And it cautions against relying on weight loss supplements.
Right.
There have been some serious concerns about the safety of those.
So it's all about those, like, lifestyle changes.
Yeah,
Definitely. For those who are active, are there any specific nutrition things we should be thinking about?
Yeah, definitely. So regular exercise has so many benefits.
Okay.
Reduces your risk of chronic diseases. It's good for your physical and mental health.
Mm.
And when you exercise, your muscles use glucose and fatty acids for energy.
Okay.
And the amount of each that they use depends on the intensity and duration of your activity. So fat tends to be the main fuel source during low to moderate intensity exercise.
Okay.
Glucose becomes more important for high intensity workouts.
And there are different energy systems that our bodies use, right?
Right. So like the ATP-PC system,
Yeah.
that's for very short bursts of activity.
Okay.
The lactic acid system for high intensity efforts that are a little bit longer.
Got it.
And then the aerobic system for endurance activities.
Okay. So we've got these different ways to fuel our workouts.
Yeah,
And then hydration is really important.
absolutely. So plain water is usually good enough, but sports drinks can be helpful for prolonged high intensity exercise,
Okay.
especially in hot weather.
Yeah, when you're sweating a lot.
Exactly. But the book says we should be careful about routine antioxidant supplementation.
Okay.
Some research suggests that the stress we put our bodies under during exercise actually might have some benefits.
Interesting.
And iron intake is also important,
Okay.
especially for women and endurance athletes, because low iron can impair oxygen transport.
So that's really important for performance.
Absolutely.
Now, food safety, that's something we all need to be thinking about.
Definitely. And the book really highlights just how widespread microbes are in our environment.
Yeah?
They're everywhere. Air, water, soil, even our bodies.
Right.
And some can make us sick.
Right. So what are some of the, common foodborne illnesses?
Well, salmonella is one,
Okay.
E. coli, and then there are viruses and parasites.
Got it.
And the key to preventing this really comes down to following some basic practices.
Okay.
Clean, separate, cook, and chill. So wash your hands and surfaces often. Keep raw meats separate. Cook foods to the right temperature. And refrigerate perishables right away.
Yeah, that's good advice.
And then there are a bunch of different food preservation techniques.
Right.
Pasteurization, refrigeration, freezing, canning, irradiation, aseptic processing.
Yeah, those are what allow us to have so much variety year-round.
Exactly.
All right. Last thing, the book talks about nutrition throughout the lifespan, how our needs change as we get older.
Yeah. So during pregnancy, good nutrition is super important.
All right.
The placenta transfers nutrients from the mother to the baby.
Right.
In infancy, breast milk or formula generally meet a baby's needs.
Okay.
And breast milk has antibodies that can help protect against infections.
Oh, wow.
As kids grow, they need nutrient-dense snacks and meals.
Okay.
Adolescence is when people often form their eating habits, but a lot of teenagers don't actually follow the recommendations.
Yeah, that makes sense.
And older adults are at higher risk for deficiencies for a lot of different reasons.
Okay.
And some of the common deficiencies are vitamins D, A, C, B12, calcium, iron, and zinc,